7.3, power functions and function operations. First of all, when you see or hear functions, you're going to see me abbreviate it as f of n. So when you see that, know that that represents a function. And for our purposes, a function is now going to be written as f of x. You can use other letters, h of x, g of x. It doesn't matter, but all of our function notation is going to be in that format. So a power function is a function that has some coefficient times a base exponent. Where a is an element of, that just means it belongs to it. It's like a backwards e or c, but a belongs to the reals, meaning it can be anything. Positive, negative, fraction, decimal, radical, it could be anything. And where x is a rational. I'm going to change the format, just the variables. I'm going to put AXB, because generally this is going to be a variable. So where b is a rational, our exponent is a rational, meaning some kind of fraction. All right, the things that we can do with these is we can add our functions, we can subtract them, we can multiply them, we can divide them, we can do all of these things. So let's say I have f of x is 3x to the 1/3 and g of x is 2x to the 1/3. If I said add them, you would say 3x to the 1/3 plus 2x to the 1/3 is 5x to the 1/3. If I said subtract them, you would say 3x 1/3 minus 2x 1/3 is x to the 1/3. And the domain is all real numbers. Meaning x can be anything. It can be positive, it can be negative. There are no restrictions on this. I can put anything in there I want to. Okay, let's look at f of x is 4x to the 1/3 and g of x is x to the 1/2. If I ask you to multiply them, you would say 4x 1/3 times x 1/2 is 4x, add your exponents, 5/6. If I said divide them, you go 4x 1/3 divided by x 1/6. Now I'm subtracting 1/3 minus 1/6 is negative 1/6. But when you divide, you have to be careful, because when you're dividing, you can never divide by a 0. So you have to tell me the domains. The domain of f is all reals, because it can be positive and negative, because this is the cube root of x, and I can have anything positive and negative and take a cube root of it. The domain of g, well, this is a square root. Square root, the domain of g can only be x greater than or equal to 0, because it has to be positive. And it can't be 0, so it's just greater than. Oh, sorry. That g is greater or equal. But now when I divide f and g, g cannot be 0, so therefore its domain has to be greater than 0. So g can be greater than or equal to 0. But when I put that division together, g can no longer be 0. So therefore I have to exclude the equal to part. And since f is everything, it makes no exclusions. All I have to care about is g. But you are going to have to know your domains. You're going to have to know what x values are allowed to happen and which ones are not. The next thing you're going to do with them is you're going to make composites. And it looks something like this. F of g of x. What it means is we're going to substitute the value of g into f. Whatever g is, we're going to put into f. So if I have f of x is 2x to the negative 1, and g of x is x squared minus 1. And I say find f of g of x. That means I'm going to put g into f. Well, f is 2 minus 1. So what am I putting into the x location of the f? G. So x squared minus 1. And the negative 1 means cross the line, change the sign. So if I reverse this and do g of f of x, it means I'm going to put f into the g equation. Well, the g equation is something squared minus 1. That something is f, 2x minus 1. Do some simplifying, we get 4x negative 2, so 4 over x squared. If I do f of x, that means I'm going to put f into f. So here's f, and what am I putting into it? I'm putting f. So here I got 2 to the negative 1 and x to the positive 1. So that makes 2x over 2, which is just x. So what is the domains? Well, the f domain is 2 over x, because 2 over x minus 1. It's x cannot be 0. It's everything except 0. G. Well, G is just a parabola. It's a square. So that's everything. So now if I look at these composites and I do f of g, f of g, so that was 2 over x squared minus 1. I can't have 0 here, and g said I could be everything. So the reality is I can't be everything. I can be everything except plus and minus 1. For g of f of x, that was 4 over x squared minus 1. F said I can't be 0, and I still can't be 0. And then the last one, f of x. Well, f can't be 0, so I still cannot be 0. You have to consider what makes a problem, and then you have to consider it the whole way through. And that's 7.3.